Hello students, we're going to learn section 3.5, equation solving and modeling. For any exponential function, f of x equals b to the x, if b to the u is equal to b to the v, then u equals v. What they're saying is if the base numbers are the same, then you can set the exponents equal to each other. For logarithmic functions, f of x equals log base b of x. If log base b of u equals log base b of v, then u equals v. Again, if the log bases are equal to each other, then you could set these terms equal to each other. Alright, so let's solve. Solve example 1. We notice that the variables in the exponent. Now, what we did in the last section is I taught you how to take log on both sides or ln on both sides. Well, here's another way to do it. So I'm going to divide 20 on both sides. So this 20 over this 20 reduces. 5 over 20 reduces to 1/4. What I'm going to do is I'm going to try to make this number, this base, look like this base. So I know 1/4 is equivalent to 1/2 squared. 1/2 squared is the same thing as 1/4. Well, since 1/2 and 1/2 equal each other, since the bases equal each other, then we could set the exponents equal to each other. Then we have x over 3 equals 2. Multiply both sides by 3. These 3 reduce to 1, so x equals 6. Alright, if we substitute 6 back in, 6 over 3 is 2. 1/2 squared is 1/4. 1/4 times 20 is 5. So you can check your answer. Alright, here is example 2. Okay, so example 2, we have the natural number to the x minus the natural number to the negative x. So e to the x minus e to the negative x over 2 equals 5. What I'm going to do now is I'm going to multiply both sides by 2 because I want to get rid of the fraction. So we have now e to the x minus e to the negative x equals 10. I'm going to subtract 10 on both sides. So we now have e to the x minus e to the negative x minus 10 equals 0. So from here, I need to get a quadratic, so we could use the quadratic formula. So the next thing I'm going to do is I'm going to multiply everything by e to the x. When I do that, e to the x times e to the x is e to the 2x, because when you multiply base numbers, you add the exponents. E to the x times e to the negative x is going to be e to the 0. And e to the x times negative 10 is negative 10 e to the x. So now you notice we have a quadratic equation. Highest degree is 2. Okay, so this is now e to the 2x minus 1 minus 10 e to the x. I'm going to write this in standard form. Highest degree first. So we have e to the 2x minus 10e to the x minus 1. And so you can see that it is a quadratic. I'm going to let w equal e to the x. So wherever I see an e to the x, I'm going to replace a w. So we have w squared minus 10w minus 1 equals 0. We're going to use the quadratic formula. So a equals 1, b equals negative 10, c equals negative 1. When we substitute it in, we get w equals 10 plus or minus 100 plus 4 all over 2. Okay, so we're going to simplify this. 10 plus or minus 2 squared root of 26 over 2. This reduces to 5 plus or minus radical 26. So when you go from this step to this step, we reduce it. So we have now, since we said over here w equals e to the x, well, I'm going to replace e to the x for w because we said here w equals e to the x. So I replace it here. So e to the x equals 5 plus the square root of 26, or e to the x equals 5 minus the square root of 26. This, you take ln on both sides. So natural log of e to the x is just x. So this is now 2.31. If you try to take ln of a negative number, because this is going to end up being a negative number, it will not exist. So the answer is just x equals 2.31. All right, next. We have now the x is here. So since the base, this was the original problem in blue. Since the base is 10, what I'm going to do is I'm going to put a 10 underneath this expression, underneath this expression. So whenever you have 10 to log base 10, remember they undo each other. And now you just have x squared equals 10 squared. Well, x squared equals 100. Take the square root of 100, x equals plus or minus 10. So this is one way to do the problem. Another way to do the problem is just use the definition of log, where you can rewrite log into exponential form. Since the base is 10, this is now 10 to the squared, and this x squared goes to the right side of the equal sign. So this was the definition of log in what you copied in 3.4. So we end up with the same answer. So two ways to do the same problem. And some of you might ask, well, how come negative 10 is a possible answer? Because when you put negative 10 back in for x and you square it, you get a positive outcome. So it's still log of a positive number. All right, so the reason why negative 10 works again is when you substitute negative 10 in here, you're going to square negative 10, then you get a positive number. So log of a positive number, you'll still get a value. All right, example 4. We have ln of 3x minus 2 plus ln of x minus 1 minus 2 ln x. Well, I'm going to condense this. We condensed from the last section. So when we condense, we use the product property. So this is equivalent to this. What I did was I moved the 2 in the exponent. So since these are the same, remember, if these are the same from the front of the page, we could set this equal to this. So now we have 3x, the quantity 3x minus 2 times the quantity x minus 1 equals x squared. Distribute, combine like terms, subtract x squared from both sides. We have 2x squared minus 5x plus 2. From there we'll factor and solve. So we were able to factor this trinomial to 2x minus 1 times x minus 2. Set each factor equal to 0. So now we have x equals 1/2 and x equals 2. But keep in mind, this value has to be positive. So if I substitute 1/2, that's fine. If I substitute 1/2 in here, 1/2 minus 1 is negative 1/2. So that makes this extraneous. This is an extraneous solution. So again, the value in this parentheses has to be positive. If I put 1/2 here, you'll get a positive. Again, if I put 1/2 here, you'll get a negative value. So we cannot take the log of a negative value. It's undefined. If I substitute 2 in here, it'll be positive. Substitute 2 here, it'll be positive. 2 here will be positive. So x equals 2 is the solution. X equals 1/2 is extraneous. All right, that's it for today. Have a good day.